Okay, finally, let's look at some identity problems in this section. So I want to look at number 35. And they want us to prove the identity. In 35, the identity is sine of 2x equals minus 2 sine of minus x times cosine of minus x. Okay, so with an identity problem, you might argue that this side is more complicated looking because it has more stuff going on. But my advice is anytime you have a half angle or a double angle or something like that appearing, it's more or less always the case that that's the more difficult side. So that's the side you should start with. So that's what I'm going to do. Remember, for identities, you want to start with the side that is more difficult. So I'm going to start with the left. And I'm going to say, well, sine of 2x, well, I can use the double angle identity, this one on the side of the screen here, that it's 2 sine x cosine x. Now, at this point, it probably feels like I have nowhere to go. But I look at where I'm aiming to be. And I have to remember the even property of cosine, that cosine of minus x is cosine x. So I'm really able to replace, this cosine x here with cosine minus x. That'll take care of that. But what about the sine? Well, that's the odd property, and it says that sine of minus x is minus sine x. So that's not quite what I have. I only have sine x, but if I multiply by minus 1 here, minus 1 times minus 1 on the right is just a 1, so on the right I would get sine x. But on the left, I actually get negative sine of minus x. So that's the other interesting identity here. I have this. This one is this. So the path forward is pretty clear, I think. I'm going to replace sine x with minus. So I have this 2 kind of hanging around. Then I have minus sine of minus x, because that's identically equal to sine x. And this cosine x I'm going to replace with cosine of minus x. And then I just kind of clean the thing up. So 2 times minus 1 is minus 2 sine of minus x, and then the cosine of minus x comes along for the ride. And that's all there is to that. So that one's pretty easy. Let's move on. Let's look at number 37. So number 37 is another identity. So prove. And we're interested in, this one's much more complicated looking. Sine of 2 theta over 1 plus cosine of 2 theta times tangent squared theta is equal to tangent theta. Now, I think there's probably no disagreement in this case that the left side is much more complicated. So we'll start there. So start with the left. And remember, with identities, you always start with one of the sides and arrive at the other. So we get sine of 2 theta over 1 plus cosine of 2 theta times tangent squared of theta. Now, my general advice from earlier about having trig functions that are not sines and cosines, oh, I dropped something, is that you should replace them in terms of sines and cosines, sort of always. So in this case, I'm going to replace that tangent squared with sine squared over cosine squared, because again, having fewer different types of trig functions makes your life easier. The sine of 2 theta, I'm going to use the double angle identity, so 2 sine theta cosine theta. And on the bottom, I have a few options. If you think about it, I have 1 plus. So if I could pick a cosine of 2 theta that's going to be something minus 1 or something like that, then that might make my denominator simpler. And if you look at the 3 options, if I chose this first one, my denominator might be messy. If I chose the second one, then I would end up with a denominator of 2 minus 2 sine squared of theta, which is fine, but it's kind of clunky looking. But if I chose this third one, then that minus 1 that's appearing is going to cancel that 1 there arithmetically. So that's the best option here. 1 plus, and I'm going to use that third identity, that cosine of 2 theta is 2 cosine squared of theta minus 1. So I've replaced that cosine of 2 theta with this. Now, again, it looks like I've made things worse, but I've actually simplified it. I no longer have that double angle there or there, and now I'm going to get rid of that tangent. So yes, I have written a lot more symbols than I had before, but it's the same principle of sort of cleaning your room. You got to make it a little messier before you can make it a little cleaner. So we've done a lot of good work here. So the first thing is that 1 minus 1 is 0. So those are just plain out gone. Okay, we don't have to worry about those anymore. The 2 here I'm still a little concerned with, but I'll worry about it in a minute. Let's clean up what we got here. Now remember, our goal is to end up with tangent. So I have 2 on top. I have a sine theta and then a sine squared theta. So really I have a sine cubed theta upstairs. Then I have a cosine theta upstairs. Okay. And then on the denominator I have a 2 cosine to the 4th theta. Now that seems horrific. What am I going to do with this? Well, let's see. I'm not really sure at this point, but I'm sure we'll figure it out. First, let's cancel what we can. So we can cancel the 2's. We can cancel that cosine theta with one of those and leave us with 3 in the denominator. So we're left with sine cubed theta over cosine cubed theta. Now, what do we do with that? It must be a typo in the book, because there's not really a way to simplify this. So I believe this problem actually was sine cubed over there. It's the only way that makes sense to me. So then we're done. Okay. There's not really much else we could do. We could try to use, some kind of Pythagorean identity or something, but it's not gonna cancel things very well. So I think that the original problem probably should have had this power 3 here, and they just forgot to include it. And so that's what we get. So again, on the exam and all this, I will only give you, that I write anyway, I will only give you problems that actually work. And so if you ever have questions in these and you think you're stuck, email me, and we'll determine if it's a problem or not.